So let us design a lap joint for two ISF plates to carry a factored load of 250 kN using M20 bolts. So here the plates to be connected are 210 mm by 8 mm. So 210 mm is the width, 8 mm is the thickness. This is the width, this is the thickness. Now these two plates to be connected to transfer a load of 250 kN. Of course, that is the factored load. So these two are the plates. They have the same width. So 60 mm is the width, and of course thickness of the plate is 8 mm. 8 mm is the thickness. So that means the gross area of the plate is 210 mm is the width. So 210 by 8. So it is 1680 millimeters square. So these two plates, they have to carry a load of 250 kN. This is factored load P, like this. So this is the connection. So this is one plate, this is the second plate. Now we have to connect these two plates using bolts. So we have to find out the diameter of the bolt is given as 20 mm black bolts. Only thing is we have to find out the number of bolts as well as the pitch, suitable pitch. So as well as pitch we cannot assume. Let us calculate the pitch to have the efficiency maximum, efficiency of the joint maximum. Now, first step is to find out the strength of bolt. This has been explained already in my earlier video. Since this is a lap joint, only one shear plane will be there. So this is how the shear plane will be. This is one plate. This is the overall length of the connection. Of course, we are going to connect these two plates by bolts like this. We have to find out the number of bolts here. Load is transferred like this. This is P, which is 250 kN. Now we have only one shear plane here, and the load is applied like this. So this is the shear plane. Since there is only one shear plane, we can calculate the strength of bolt in single shear. So the formula already we have used Fu by root 3 into 0.78 times the area of that bolt, pi d square by 4. So if you simplify this, of course here Fu is FUP, which is nothing but the strength of ultimate strength of that bolt, which you can get as 400 into pi d square by root 3 into 0.78 into pi into 20 square by 4. So this is the value of the strength of bolt or bolt value. So if you simplify this, so you will be getting pi into 400 divided by 4 is pi into 100. So it is pi into 100 into 0.78 into 400 divided by root 3, which is 56.59 kN. Of course, this should be divided by gamma MB. So that means it is divided by gamma MB is 1.25. So the value becomes now 45.27 kilonewton. So this is the strength of bolt. So this is in newtons, that should be converted to kilonewtons. Of course, in the case of a lap joint, strength in shear is the criteria, because normally the strength in bearing will be greater than the strength in single shear. Therefore, we can take bolt value or strength of bolt as 45.27 kilonewton only. Now the number of bolts required to transfer a load of 250 kilonewton is this 250 load divided by strength of bolt 45.27, which you are going to get it as 250 divided by 45.27, which is 5.5 to say 6 volts. Say 6 volts. But we have to arrange these bolts now. Let us see how we can arrange the bolts in different ways. Suppose if you are providing all the 6 bolts in one row, then the length of connection will be very high. So therefore, better you arrange the bolts in 2 rows or 3 rows. So let us provide bolts as shown in this figure. Now let us see how we can arrange the bolts. So since you have 210 mm here, this side, width of the plate is 210 mm, you can go for 3 rows of bolts. So 210 mm definitely it can accommodate. So this is how we can show the bolts. Here, so this comprises of one plate. This is one plate. Of course, this plate runs in this direction, and this is the second plate. IS flats means plates. IS flats. So this is 210. As you know, this is 210 mm. We can definitely provide 3 rows here. 1, 2, 3. 1, 2, 3. So totally 6 number of bolts we have to provide. I am providing 6 bolts in 3 rows. So this is the arrangement of bolts. Now once you arrange the bolts, now we can find out the pitch that is required. So based on the criteria of equating the tensile strength of the plate to the strength of connection to have maximum efficiency. Now what I can do here is per pitch length I am going to calculate. Now let us use this concept. So one pitch length is this much. This is one pitch length. One pitch length. In one pitch length, you have 2 bolts, or you can take from here to here also, center of bolt to center of bolt. So if you take center of bolt to center of bolt, then also you get 2 bolts in one pitch length. Half. If you take like this, then also you will have 2 bolts. So in one pitch length, there are 2 bolts per pitch length. So this is one pitch length, that is P value. This is the value of P. We have to find out P now. So there are 2 bolts per pitch length. Therefore, what I can write is strength of bolt or strength of connection per pitch length. It will be there are 2 bolts, therefore I have to multiply this by 2. So strength of 1 bolt is 45.27. And since there are 2 bolts in one pitch length, into 2 we have to take, so it becomes 90.54 kilonewton. 90.54 kilonewton. This is the strength of connection or strength of bolt per pitch length. Now equating this to the net tensile strength of the flat per pitch length. Net see this wording, net tensile strength of flat per pitch length. Flat is nothing but plate. So this we can obtain from the code. So in that page number, I think design of tension members, it is given. In the last class also I had explained about it. So it is available in page number 32. Page number 32 of the code. So we can write down the formula for that. So page 32 of the code. But please note that you are calculating per pitch length. So net tensile strength, net means you have to deduct the diameter of bolt hole here. So this is given by, you can refer that page number, so 0.9 AN FU by gamma M1. AN FU by gamma M1. 0.9 AN FU by gamma M1. Here, please note that this AN, we have to take the net area per pitch length. Net area per pitch length is nothing but, so pitch is P, in that you have to deduct here, you have to deduct one bolt hole here. So I am taking the width, so width here is 210, from this 210 one pitch length is P, from this P you have to deduct this one bolt hole, that is GH, and thickness here. So this gives the net area. So now that means here, this is P minus 22, because diameter of the bolt is 20, diameter of the bolt hole is 20 plus 2, clear as? So 22 into T is 8 mm. So thickness of the plate is 8 mm. So now that is AN. Now if you substitute that here, 0.9 into P minus 22 into 8 divided by 1.25. Gamma M1 is 1.25. Gamma M1 is 1.1. So you have to equate these two now. So equating the above two. So that means we are equating the strength of correction with the net tensile strength of the flat per pitch length. So it is given by 90.54 is equal to 0.9 into 8 into P minus 22 divided by 1.25. So from this we can calculate pitch. So P minus 22, suppose P minus 22 is equal to so here this is in newtons. I take because here all these values it is in millimeter square, and FU will be in Newton per mm square. FU value is for the plate is 410. So I have not taken that. So into 410. So 410 Newton per mm square is the value of FU for the plate. For the bolt it is 400. For the plate it is 410. So into 410. Now from this you can calculate P. So equating these two. So P minus 22 is equal to this into this, that is 90.54 into 10 cube into 1.25 divided by 0.9 into 8 into 410. 0.9 into 8 into 410. So this is the expression we get. So P is equal to whatever you get here plus 22. So let us simplify this. So it is 90.540 into 1.25 divided by 0.9 divided by 8 then divided by 410. Yeah. So we are getting 38.33. So therefore P is equal to 38.33 plus 22. So it comes to 60.33 mm. So this is the pitch that is required to have maximum efficiency by equating the net tensile strength of the flat to the strength of connection. So we cannot provide 60.33, therefore let us provide, P is equal to 65. We will provide P pitch as 65. We will go to the next whole number. So we will take it as 65 mm. So that is the pitch we can provide. So here this distance is 65 mm after getting, and this is also 60. That means center to center it will be 65. Now end distance we can take it as edge distance. We can take it as 1.7 times d or 1.5 times d naught. Let us or whatever is remaining, that becomes the edge distance. Now let us see what happens to the value of E. So here, so since we got this as 65, I can write in another way. So this from here to here it is 65, from here to here it is 65. So remaining thing will be there. So 210 minus 130, it is 40. So therefore this becomes 210 minus 130 is 80. Therefore 80 divided by 2. So 40. So this is how we can have the connection now. Now we can do one thing. You can calculate the solid plate. This thing. So strength of solid plate, and always you can find out that value, whatever strength of solid plate is there, that we can compare with the strength of the bolt per pitch rod. So this is one of the ways of designing a lap joint to have maximum efficiency, wherein you are going to find the value of pitch. So you are not calculating the value of pitch, so you are finding the value of pitch by equating the strength of the connection per pitch length to the net tensile strength of the plate or flat per pitch length. So this is the formula we have to use to find the net tensile strength of the flat, which is available in the code. So since we are calculating per pitch length, P minus DH, that formula we are using. So you can always compute the strength of the plate now, and afterwards you can always show that value and this value you can compare. Strength of connection value you can compare. For calculating the strength of plate or flat, you are calculating using the another formula which is given in page 32 of the code, that is the formula AGFY by gamma O. So this is for the solid plate. Strength of solid flat without the bolt hole. So if you take AG here is 210 into 8 into Fy is 250 divided by 1.1. Gamma equal 1.1. This value will be in newtons. You can convert this into kilonewtons. So 210 into 8 into 250 divided by 1.1. So which is 381.82. 381.82 kilonewton. So this is the strength of the solid flat, which is greater than the load factor 250 kilonewton given in the problem. Therefore, connection is safe. Connection is safe. So this is one of the checks you can have. After providing the connection, whether it is safe or not, you can check this. This is one way. Another way, you can always compute the, after getting the pitch length, you can compute the strength of bolt in bearing. Since in the beginning we have not considered this, after finding the value of P, E, everything, so this E also you can give. This is 40 and 40 we have given. So after getting the pitch value, we can always compute this VDPB value. VDPB value will be VNPB divided by gamma M1 or gamma MB. So once again, this formula is given in page number 73 or 74 in the code, which we have already used 75. So 75 of the code it is available. So already I have used this in earlier problems in the main videos. So this V and PV we need to compute. V and PV is equal to 2.5 times AB into D into T into FU. So please note that here FU is the strength of the plate sheet. So 2.5, KB is the least of, so this we can find out only after getting the values of P and E. So this is E, this is P, 65 is P, 40 mm is E. So least of, there are so many criteria, it is given there. So least of E by 3D naught, E by 3D naught, one criteria, P by 3D naught minus 0.25, second criteria, FUB by FU, third criteria, fourth one is 1. So E divided by E is 40 mm here, divided by 3 to D naught is 22 mm, because 20 mm diameter boards, diameter of board is a DH or DO, whatever you can use. So it is 22, P is 65, we have got, divided by 3 to 22 minus 0.25, this is 400 divided by 410, and this is 1. So least among these four will be now 40 divided by 3 into 22. So let us calculate the value now. 40 divided by 66.61. This is one value. Second value 65 divided by 66 minus 0.25. Second value is 0.73. Third value 400 divided by 410, which is 0.7998. And last value is 4. So among these four, the minimum value is this. Therefore, KB is 0.61. Once you get the value of KB, substitute here. So therefore, V and PB is equal to 2.5 into KB is 0.61 into D is 20 mm diameter of the board into T is 8 mm thickness of the plate into FU is 410 of the plate. It will be newtons. You have to convert it into kilonewtons. So the value will be 2.5 into 0.61 into 20 into 8 into 410, which is equal to 100,040. 100,040 you get, so 100.04 kilonewton. So therefore VDPB is equal to V and PB divided by 1.25, that is 100.04 divided by 1.25, which is equal to 80.03 kilonewton. So beginning we have assumed that the strength of bolt is evaluated using shear criteria. Since we got the strength of bolt in bearing criteria as 80.02, it is greater than whatever 45.27 is there using shear criteria. Therefore, shear is the, because minimum of these two we have to take as the bolt value. So whatever we have assumed in the beginning, it is correct. So shear criteria is okay. So therefore it is safe now. So we have not assumed bearing as the criteria. Normally in the case of lap joint, you will be having single shear, and single shear will be the criteria for deciding the bolt value. So these are the two checks we have to do after designing the lap joint. After check 1, check 2, after getting the value of P and E by using this equation, strength of connection per pitch length to net tensile strength of plate per pitch length, get the value of P, then remaining, whatever is remaining will be your E value, After getting that, you check for these two criteria.